Welcome to qnawire.
We have another case of a gas steam turbine here. Again, we're in English units. And so we're basically just looking at the previous problem. And now we're going to, let's see here. We want, what does it say? Uh, we want be routed, we want the steam passing through the condenser to be the condenser of the combined cycle to be routed to buildings during the winter to heat them. Okay. So again, we're having steam coming out here, and we're going to try to utilize some of that steam to heat buildings, which is actually something that's often quite done, especially if there's a steam plant like on a university campus or something. You hear a lot about people talking about this steam tunnels or steam pipes in universities, or actually any kind of big um, complex where there's actually a local power plant. So yeah, at most universities they have a local power plant that runs to generate electricity for the university, and a lot of times that will then be some of the steam from the power plant will be used to heat the buildings in the winter if it's in the north or where you need heat. So let's see here. What are we gonna do? What are we saying here? So the pressure in the heating system where the steam is now condensed will have to be increased to 10 psia. So I did not change the thing that needed to be changed here. So that should be 10. So that's really the only thing that changed, other than that we're now using the heat coming out of here for something. So it would actually have a utilization factor would increase because we're now utilizing that. Everything else is the same. So let's see on here. Again, all of this stuff is basically the same as we had in the previous problem. So that's all exactly the same. This is not the same because the pressure at the pump coming into the pump is different. So we have these guys are different. So, but we can easily find what these are. This is the same. This is the same. And now P4 here is now, again, different, is 10 psia. And we can get the isentropic enthalpy. And let's see here. We can get the enthalpy here. And I just realized, well, if you're listening to this problem and you listen to the previous problem, I just realized I was talking SI units in the previous problem when I should have been talking English units. But I think you can make that conversion. So all those numbers in the previous problem were SI units. All right, were English units. Anyway, we can get the net work out of the gas side, which is going to be exactly the same as before. And so now this is BTU per pound mass, not kilojoules per kilogram. The net work out of the steam side we have is 305.7 BTU per pound mass, which is different than the previous problem here. So we have less work out of the turbine because we're going to use some of the steam because we increase the pressure to use the steam for heat. Now we can do an energy balance on the heat exchanger and get the, again, we need to fix this. That should be m dot s divided by m dot g. And now we have about 9.126% of steam flowing as compared to air. So again, getting this everything on a now it's actually a pound mass of air basis. So pound mass of air basis. This is all in pound mass of air. some pound mass of the fluid that's going through there in the combustion chamber. Here we have the compressor. We have the heat that we dumped out as we basically dumped the temperature coming out of the heat exchanger down the atmosphere. So that as the gas cooled, as it comes out of the heat exchanger. And then we have, let's see here, this is the specific work per mass of air, or per mass of steam. So we need to do this conversion factor to get it per mass of air. And so then this is the specific heat out per mass of air or gas. So BTU per pound mass of gas. And so now, again, we just do the trick, 1 minus Q out over Q in to get the efficiency. And now it's down to 45.73%. So we dropped a little bit, about I don't know, 0.8, 0.7%. But now we're utilizing a lot of, we didn't actually calculate what this is, but now we're utilizing this to heat the building. So in fact, our utilization surely went up because we're utilizing this heat for something.